continuing working on solving equations, and the important thing to keep in mind is that whatever you do to one side of the equation, you have to do to the other side also. I want to kind of undo whatever's been done to x. That's in general what I'm going to try to do. So what this problem means, if I were to turn this into a sentence, it would mean 3 times a number equals 17. Hang on a second, 3 times nothing is 17, right? Like 3 times 5 is 15, 3 times 6 is 18, nothing is 17. Except for my friends, we might get a fraction sometimes, and that might freak you out, but I promise it'll be okay. Let me show you how this works. This means 3 times x, right? And in order to solve an equation, I want to do the opposite of timesing, which is dividing. So if I divide both sides by 3 like this, then what you know about fractions is that 3 over 3 kind of cancels out. It's like a giant 1 right there. 3 over 3 as a fraction is like the number 1. So what I really have is that x equals 17 thirds. That's my fractional answer. Don't freak out. Like 17 thirds is a weird number. We probably don't see that very often. But it can still work. It can still be the solution to this equation. And just so you guys believe me, let's do a quick check. On my paper, I would write like, hey teacher, here's where I'm checking my solution. And I would say 3 times 17 thirds, I hope, is equal to 17. And then, to make sure this is true, think about what you know about multiplying fractions. If I turn this into 3 over 1, then I can see that my 3's would cancel out, just like that same giant 1 situation, and I'd be left with 17 equals 17. Sweet. So what I want to show you guys today is like, you don't always get a whole number. You don't always get x equals 5, x equals 10. Sometimes you get x equals 17 thirds. Don't freak out. It still works.